This is a very brief tutorial on how electrical stimulation may be used in physical therapy. So right here I have listed sort of the primary uses of E-stim in PT. We start over at the left with TENS, and then IFC, Ionto, and NMES. So those are your four primary modes of electrical stimulation. And we're going to start by talking about what you would use these various types of electrical stimulation for. What symptoms, why are we going to use them? So the first kind of a primary one we've talked about in class is pain. We may also use these types of modalities to control inflammation. And then finally, we may use these types of electrical stimulation for muscle re-education, or even sort of muscle pumping to control edema and swelling. And so you can see here I've kind of used the color coding to orient you to how these different types of stimulating currents might be used. So TENS and IFC are primarily used for pain control. When we're looking at delivering medication to control inflammation, we're looking at Ionto. And it is worth noting that Ionto can be used to deliver medications for other types of symptoms, but primarily in PT we see Ionto used to deliver meds for inflammation. And then finally NMES, as we'll call it, but we also, your high volt and Russian currents kind of fall under this. We use the term NMES in class, but your Russian and your high volt kind of fall in this category too, of the types of currents that are used to produce a muscle contraction. And so many of your NMES machines, so-called NMES machines, actually use that Russian current. And the NMES, or just the muscular contraction, often is used for muscular re-education and strengthening, and also maybe a less intense contraction may be used for muscle pumping and to control edema. So these are your primary uses. Now when we get back over to the left side and looking at pain control, when we decide we want to use electrical stimulation for pain control, we usually are going to use TENS or IFC. Then we have to decide how we're going to set that machine. So we primarily want to figure out what stage of healing is that patient in. And so we look at the acute, subacute, or chronic phases of healing. And if our patient is more in an acute phase of healing, we're going to want to go towards settings that are considered kind of conventional TENS. So I'm going to just kind of abbreviate that with a CONV, but that's kind of a conventional sensory level TENS. The purpose of conventional sensory level TENS is to stimulate those larger sensory fibers, providing pain control via the gate control theory of pain relief. So with conventional TENS, we use a frequency of 80 to 125 pulses per second in general. If we can set the pulse width, we're going to set it kind of in the 70 to 150 range. And we often want this to be a continuous current, and it's going to run for maybe about 30 minutes or so to get that pain relief. So that's kind of where your acute setting is. Now, if you're in the subacute stage of healing, we may want to use TENS and what's called a motor level TENS in your book. And so to stimulate those motor fibers, we want the setting maybe from 20 to 70 pulses per second. The pulse width is going to be a bit wider, so maybe 100 to 600 milliseconds. And this may take a little bit longer, so we may do this treatment as short as 15 minutes if we get that pain relief, but this one may take longer, so we may have the patient use this type of treatment in the subacute phase for up to 60 minutes. And then finally, if that patient's in the chronic phase, we're going to use what we refer to as a kind of a noxious level TENS. And for that noxious level TENS, our pulse width is going to, or pulses per second are going to be from 1 to 10. So much slower frequency. Our pulse width, if we can set it, is going to be much higher because we want that longer pulse width to stimulate those pain fibers. So we may be up to 1,000 milliseconds for our pulse width. And again, this one may take a little bit longer, so the range of how long this treatment may be provided is up to 60 minutes. So that's kind of our pain control, how we would use TENS and IFC. Now remember, if we decide to use IFC, IFC allows us to do that kind of scanning or sweeping mode. IFC that is different because it allows for a quadrupolar application. And remember, because IFC is a higher frequency, your carrier frequency is typically set at about 4,000. And so you're going to set your other frequency at a rate so that when they cancel out, you're falling into one of these three categories. So because of that, high carrier frequency, IFC can be more comfortable. It does allow you to provide the electrical stimulation sort of in a larger area and sweep it over an area. So there are some considerations of why you might use one over the other, but in the end, TENS and IFC kind of are for the same purpose and work via the same mechanism of controlling pain. So moving on to ionto. Ionto is pretty straightforward, and again, iontophoresis is used to deliver medications using electrical stimulation. And primarily in physical therapy, we're going to see the types of medications that are used to control inflammation. And so this is a pretty straightforward process. Your medication is going to have either a positive or negative charge, and that's important to know. And then we're going to actually deliver that medication. We're going to put that medication onto an electrode, and we're going to put that active electrode over the site of inflammation, and we're going to deliver that medication using a direct current, and we have to make sure that we have set up our electrode so that it's delivering a current that's the same polarity as the medication. So for example, if your medication has a negative polarity, you want to set up your iontophoresis treatment so that you connect your lead wire, the negative lead wire, to the active electrode. So you have a negative lead wire connected to an electrode that's been prepared with a negative solution. Using some of the newer machines, those actually have a plus minus on the pad, so you just put the solution on the electrode that has the polarity that is the same as that solution. And then you're going to deliver the treatment. It's dosed in milliamps per minute, and so depending on the machine, the standard delivery of iontophoresis, you're actually going to take the intensity, your milliamps, multiplied by the number of minutes, and that's how you get your milliamps minutes. So for example, a dosage of 40 milliamp minutes might be 4 milliamps for 10 minutes. Again, on some of the newer machines, there may be different sort of modes and settings where you may actually, the duration may be much longer to produce that same dosage. So you do need to check with the manufacturer. But know that your time on the machine is a function of the dosage you want of that medication. And then finally moving on to what we've called in class NMES, or neuromuscular electrical stimulation. Again, oftentimes using high volt or a Russian current. These are the types of currents that we want to use to get a muscular contraction. And so there are a variety of reasons you may want to get a muscle contraction, but again, primarily often we want muscle reeducation, or we want some muscle pumping for edema control. So starting with muscle reeducation, you're going to set your frequency for 35 to 50 pulses per second. And that's going to become sort of in that muscle contraction range, but probably just before you get to tetany. So you're going to get that contraction there. If you can set your pulse width, you're going to sort of want to be in the 300 to 600 range for your pulse width. And again, remembering that that's sort of the pulse width that's needed to stimulate those motor fibers. You're going to set an on-off time when you're doing electrical stimulation for muscle reeducation. And there's really sort of a range of how you may set that. Oftentimes we do a 1-to-4 ratio. So for example, you may have a 15-second contraction followed by 60 seconds of rest. But that can really vary based on your goal for the patient. So some literature will say give ranges up to a 1-to-7 ratio or more, whereas other clinicians and sources are setting it 1-to-1 or 1-to-2. So really there's a wide range, but know that the kind of the higher that ratio, the shorter the off time is relative to the on time, the more likely you're going to get fatigue in that muscle. You may set a ramp time for NMES as well, and that's just for patient comfort, so that when that contraction starts, when that stimulus starts, it doesn't just hit as a maximum contraction all of a sudden, that you might set a couple of seconds of ramp so that that stimulation gradually ramps, and so the contraction gradually comes on. And usually for this purpose, you're going to be 10 to 15 minutes total. That's really for patient fatigue purposes, that after about 10 to 15 minutes, you might see some fatigue happening. Similarly, if you're using electrical current for muscle pumping, for edema control, your frequency is going to be the same. So you're going to be, again, in that 35 to 50 pulses per second. You don't want tetany, but you do want a nice contraction. A big difference here, though, between using E-stim for edema control versus muscular reeducation is that you're probably going to have a less intense contraction. So for muscular reeducation, and especially for muscle strengthening, you're going to want that really strong, intense contraction. When you're using it for edema control, it's going to be a much weaker contraction because you're really just trying to get some muscle action to pump the fluid out of that area. Your pulse width is going to be the same because, again, you're really doing the same thing. You're just trying to stimulate the muscle fibers. But because because your contraction is much less strong, and because you're trying to get a lot of contractions to pump that fluid out, your on-off time ratio is probably going to be more like 1-to-1. So it's very typical for this use to set a contraction of 5 to 10 seconds with an off time of 5 to 10 seconds and kind of alternate that. And because it's a less intense contraction, 20 to 30 minutes oftentimes is indicated for this use, and the patient's going to tolerate it a little bit longer than that. So this sort of, in a nutshell, takes you through the considerations you need for this course, your lab practical and clinical practice for electrical stimulation.